Hey everyone, I'm going to be going over some of my lecture slides from my course, and this is mostly just to help me and anyone else who wants to watch and learn together. So this was day two. Some of the stuff is not relevant for everybody, but let's just go over some of the content that they have here. Let's also look at this example link that they posted. There's a lot of like breakdown for the quizzes in the material. But let's see when the actual content actually starts. Yeah, so this could be good. So they made an example data frame with the first name had a character, last name had a character, height was a numeric quantity, weight was a numeric quantity, there's strings as factors with false. There's basically an indexing, there's a list made with first name, last name, and height and weight values, which are all defined in this example up here, and then they're posted. And then he expanded this data frame. He used rbind. So we still have the same information. It's being pasted. It looks like it's going 4 to 100. Not really sure what this does or means. The height and the weight are rounded with R norm. And it's giving it like standard deviation values, it looks like. So sample size 97, mean is 5.8, standard deviation 0.25. I don't see any formula defined here, but it is going to round the information. And I think we can see outputs in the RStudio code, so maybe I'll show those after. So rbind is the row bind function. If you have a data frame, it adds more rows. It stacks on a data frame on top of the other and makes sure that the data frames have the same number of rows and the column names are the same between the two data frames. Paste function, paster function can be used to paste text together. If you paste together as a string with the vector of numbers, and the output is a character vector with the string pasted, so to each of the numbers in the vector. So yeah, we'll look at some of these functions later. But let's just look at the larger example data set. So they also show how to save the example into a file, which is example RDA. It's an RDA file, so it's saved to a working directory. And get working directory can show you where your working directory is at. Then you can set working directory to put yourself in that relevant directory. And keep in mind the forward slash versus the backslash. Okay, I guess he was asking a question how to convert it to feet based on height, and then he was asking for average weight. So which function? He made tall people. He said example. Which example with height is greater than or equal to 6? So this is one way to get it in feet. And then he had the variable with the specific weight column. And it can be done in one step. So mean example, which example height for weight. Writing the name of the column or columns, if you want to select multiples in the column, it's a way to extract the particular column from the data set. If you want both the height and weight columns, then you do this. Another way is to use the filter function from Dippler. So he said tall people with the example this greater than with a filter of height greater than or equal to 6. And then he said mean of tall people with a weight is something to keep in mind. You could use Dippler's summarize function, do it in one step if you don't really want to clutter the workspace. Okay, so you apply the Dipper again with a filter of weight and has a greater than, and then it's summarizing the weight. So this, I guess, is a summary of creating variables, objects, storing them in environment, creating data frames and vectors, columns of data, creating lists of objects, subsetting and selecting portions of column vector data frame, selecting storing data in particular entries of a vector data frame list, and creating new objects from previously defined ones. Okay, so I guess there was also a review of for loops, ggplot, finance analytics, logical operators and vectors, and problem solving tips. So we'll kind of look into that as well. So the for loop, I'm just gonna open up my channel on the side to see if the stream is working effectively. Yeah, it looks like the stream is going on fine. Okay, I'll put another test in there. Okay, so if you find yourself typing the same set of commands over and over again, you consider replacing with a for loop. For every web page in a list, scrape the table data on the page and store it in R. So a lot of this lecture looked at top 10 stocks for market capitalization, and you collect their historical stock price information and save those objects to the environment. So we have programming basics, the for loop. You have for I in 1 to 3 print I, so it prints these three different things. In this case, 1 to 3 is called the for loop's indexing vector, and I is the index or the variable, so it's basically just going to loop out 1 to 3. If you break it down, for loop is doing this stuff, so it's looking at the first index value, updating it, continue updating it till the last index value, and you can copy paste this chunk of code in braces for help in executing loops. The indexing vector doesn't have to be a numeric vector. It can be a character vector, a matrix, or a data frame. So you have this example text, and it'll loop through all of those. It's using the combine function. Okay, what else is useful here? So this is starting with the first index value. This updates the index, and it keeps going down until the last value. So this is a sequence that goes from 5 to 20 and changes by 5. So those should be 5, 10, 15, 20. So yeah, he's saying that you should predict what you think the future result or output will be, and then see how far you are. So yeah, this was the output that was coming from there. Then the loop is using the numeric to update the value of the index after executing the code chunk. Okay. Don't have to use I as the index. They use J in this case. You could use anything starting with a letter, I, J, K, T, and using T if the index is related to time. Typically, I is the most common index, and then you use J and K if you want further nest loops or within for loops. So for I in sequence from 5 to 20 by 5, you can print I times 10 to the power of J. So it's probably going to do 5 times 10 to the power of 1, 5 times 10 to the, no, 10 times 10 to the power of 1, 15 times 10 to the power of 1, and then 20 times 10 to the power of 1, and then it'll probably do it for 10 squared, most likely. Yeah, so I is 5, replace the 5 in there, 10, 15, 20, and then go from there, and it should give you another set of values. Having J going from 1 to 2, the workload is doubled. Yeah, and then J is 2, and then it goes up from there. You can vectorize code. Program backgrounds are not designed for you. Often use for loops within for loops. Yeah, this could cause issues. For loops within for loops. He mentioned that in lecture as well. You can save hours of time by debugging the code. What list of numbers will print to the console for I in 1 to 5? So it'll be probably 2 times 1 times 2 times 3 times 4 times 5, but I think they were getting squared. So Z is 1. Oh, and they get stored. So it's 2 times 1, which is 2. And the next one, it's 2 times 2, which is 4. And then 4 times 2, which is 8. And then 8 times 2, which is 16. So actually it gets stored. So when you define Z as 1, it stores it in this variable. So I remember that was, yeah, 2, 4, 8, 6, 13, 20. 2, 4, 8, 16, 32. Yeah. So you can use the numeric vector character to define empty numeric and character vectors, which can be useful for a for loop when you need to store things in a vector. So this makes an empty numeric vector, Z is 1, and then you can store Z as the ith entry of a Z vector, and then go from there. So you can practice taking a chunk of code with very similar lines of code. You basically have each line as a copy paste of the previous line with a modification and make it into a for loop. So what's he trying to do here? Just printing out different numbers. So he's saying, how do you get a for loop to do that? So yeah, it's changing by 2. You can have it go from 2, I guess 1 to 5 maybe, and then have like a loop changing by 2, something like that. Or he said 2 to 10 by 2. It's actually simpler. So for I in this sequence from 2 to 10 by 2, you print this. Okay. Taking a chunk of code with a very similar line of code. Each line is copy paste the previous line with slight modification. So you start with 1, becomes 1, 2, then 1, 3, 1, 4, 1, 5, I think. But let's see. So we said x belongs to 1 for I in 2 to 5 because it started from 2 and then went to 5. Then you write the x is equal to combine of x and I. So x is defined, I is defined up there. X is a numeric 0 for I in 1 to 5. X of I is I. Okay. That was faster in the second one. We got a for loop to replicate the output. So these two are defined, and then this is where the pattern is. So 3 minus 2 is 1, 3 minus 1 is 2, so that'll be defined there. So it's basically, see a pattern copies line code, that thing gets modified, will somehow relate to the indexing variable. which is I in this case. So x is numeric 0, x of 1 is 1, x of 2 is 1, for I in 3 to 10, because it was going from 3 to 10. They defined x of I is x I minus 2. So x of I was this, I minus 2 is this, and that would be I minus 1. So I minus 2 is this, have it in brackets, square brackets is stored in a variable, have the for loop start with I, defines where it's at, and then they square this eventually. In each copy paste line of code, 3 numbers change, the index you'll assign to the left of the assignment operator and the other 2 indices on the right of the assignment operator. What else? For loop is not necessarily the fastest, most efficient way of doing something. If you want to create a vector whose elements are the difference of consecutive squares of all numbers, you could do this, 1 squared minus 0 squared. I don't really understand why they would want to do this, but they asked how to do it without for loop, so, or wait, how would you do this with a for loop and how would you do this without a for loop? So he said that for I in this 1 to 1 million, you do x of I squared minus I minus 1 squared. So if I was 3, it would be 3 squared minus 3 minus 1 squared, which is 2 squared. And then it would repeat that. Yeah, so it kind of looks like this. And then it goes and so forth. This without a for loop, he just split it into 2 pieces, 1 to 1 million index squared minus 0 to this number squared. The system time function is a useful function when you're trying to figure out how to speed up code. You can compare different ways of implementing a solution approach to see which is faster. So yeah, this shows how much time is passing with those functions. So more time seemed to pass in this loop. So user system allows remove x from the environment, okay? X for I in this. Yeah, this one seems like it took longer. Vectorizing code, removing for loops by applying functions to vector data frames typically will speed up the runtime code. All of the languages meant for working with these numbers are vectorized for computational efficiency. What that means is that sometimes slightly, sometimes dramatically, you can get faster for the computer to run the code if it's being vectorized with for loops replacing them with functions. Vectorizing is a form of parallel computing, sending the CPU instructions to do the computations at the same time. In a for loop, the instructions are carried out one at a time, unless you add in further instructions to carry the for loop out in parallel. Vectorizing sends instructions to different cores on machine. Okay. Sample data frame X is numeric, Y is also numeric, so it defines the 2 variables, puts in a data frame for I in 1 to 100 index. Example data I with the 1 is I, example data I with 2 is that plot, so it makes a graph. It's an exponential curve going up. Can you repeat the plot without using a for loop? This looks like it's the same plot. Not really sure how they did it. They just made a general plot, x 1 to 100, now their index, y 1 to 100 squared, x lab, y lab. And then it seems like they'll graph it. And then, okay, that was for loops. They're going to go into ggplot soon. R's plotting vector is not good, so you use a better graphics package. And then the data can also be exported to Power BI or Tableau. Okay, so this package is installed. You can use the package in the working session, load the library. So it also says note if every time you close RStudio restart R, the working session will be restarted. So it clears the memory of global environment data and packages loaded. If you've loaded the package, you can use functions within that package. So you can use the qplot function to quickly plot something. Qplot has been deprecated by developers of this, so it'll still work. Okay. Let's keep going. I think we're almost close to halfway done. 80 slides would be halfway, so this is ggplot. You can also flip the curve to points by using the geom argument, so this makes it smooth, it looks like. Made it a smoother graph instead of a dotted graph. Scatterplot points now fall neatly onto the smooth curve. You can see it as a fitted curve, so they added geom, C, point, and smooth, so that fitted it on. Indexing is still there. They also have a normal distribution, it looks like, with n is 100, mean is 0, and standard deviation is 500. Blue curve we see on the right because on the same as the previous slide. Okay. Polynomial regression model to fit the best data points. Yeah, that looks like this is adding the polynomial regression. Yeah. Okay, so there's points on here and there's a line which is being fit, which is probably coming from this geom point smooth and the R normal function. Standard ggplot. So data frame, have the x value, the y value, the R norm, and then ggplot will be connected to the data frame. I forgot what EES stands for, but it's telling the X and Y values. You can add GM point and smooth, and the labs have the labels. Examine stock price prediction using QuantMod. Okay. Open source language so anyone around the world can write packages and make them freely available. Okay. Tons of packages for almost any setting you can apply in Linux too. Packages depending on whether updating a package may interact with the functionality of other packages. Okay, this checks the R version, tools, global options, look at R. If you have Windows, you can update R from within the studio. You can go back to an older version of R. Okay. Packages break down for other reasons. Package will cover a bit in QuantMod, pulls data from sources like Yahoo Finance. Okay, yeah, so sometimes if the Yahoo Finance makes changes to the API, it will break the QuantMod package. He mentioned that in class as well. Developers will come back to monitoring issues. Okay. Package developer might suggest temporary workarounds while they fix the package, and either function will be fixed or become defunct in a newer version of the package. Okay. Functions calling the offense will no longer work, and newer version of the package would no longer have functions. Okay. Come up with a fix. Okay. Developers are still testing out. Okay. Just telling about debugging. Okay. So installing the package from QuantMod, it gets its data from Yahoo Finance and then the US Federal Reserve. In order to be able to use the function of the package, you'll need to load the package in a global environment. Yep. You have to load the package every time, so you start a new session in R. Okay. This helps you with the help information. It tells you what the QuantMod package does. Right, so you can look at the Tesla stock price over time. I'm just gonna see if anyone's commenting on the video as well. Not yet. Okay. It's always nice to see if anyone's there. Okay, so if you look at the Tesla stock price over time since August 1st of 2017, it gets all the stock prices on or after this date. You can use the get symbols function from the QuantMod package. So you have symbols, you get symbols for Tesla, source from Yahoo. The left out source equals I, you get the same data. Oh, okay. So automatic returns are called Tesla, which is an extensible time series object in R, which is a data structure specific to time series, right? He mentioned in class extensible time series. Time series sequence of values over time, taking in future values. The time series depend on past values. We won't cover time series. Okay, oh, it's outside the scope of class. Okay, plot the evolution of prices. Avoid working time series for final projects unless you've seen. Okay. Okay, let's get symbol functions built by the authors. The one we can store the data in the environment. Okay. Store the output get symbols. Set the environment parameter null. Output is not the same environment. Convert the output to a data frame instead of an XDS object. So you can convert it to as data frame with the different values. Environment null. Tells get symbols not done. Store the data as Tesla. Okay. Different data structures and classes of objects in R. Extensible time series is designed to work better with time series data. Functions that work only with extensible time series but not regular data frames. Okay. Due to data sense identical, they may not be able to apply the same function. Okay. Tesla stock charts. .xts get symbols. Okay, look at the structure of this object. So it's just comparing the two structures. Okay, these two look identical. View function, make sure you have to be capitalized. Okay, click on the name and open it so you can see data. Lets your teammates know that you should look at the data, okay? What else? It's indexing. Tell the roll number of the observation. You ran the get symbols function. Create an XTS. Okay. If you have a data frame that was converted from a time series object, you can use the roll names function directly to get the dates. Okay. About the closing price of Tesla over time. Index.tesla. Okay, I want to plot the closing price over time. Define a data frame. This is on slide 97. Okay. Okay. About the closing price of Tesla over time, get the observation for each price record. What else? Do index Tesla. Suppose we wanted to plot the closing price of time to find a data frame. Want to have the ticker.date column be a data type, so use the asDate function, okay? Closing price should be a number, so use the asNumeric function, okay? Data frame ticker.date asDate index Tesla. Closing price asNumeric. Tesla close. Okay. What else can we see here? So give a ticker date function, which is new, set to have it as as.date. Index Tesla. Closing price was as.numeric. Tesla with the Tesla.close, okay? And stored in Tesla data. This is probably useful for the assignment on page 97. How you define a data frame based on data from previously defined objects. Qplot helps to graph the Tesla data with ticker date. Why was the X? Why is Tesla data with closing price? So ticker date matched the closing price. Looks like that. So it's pretty high in 2022 and 2025. Line plot. We can do that by changing a parameter Qplot. Okay, so you can make a line plot. Geom equals line. We'll make it a line plot. That's probably easier to see. And change the labels to date and closing price. So now those are changed. You can add and center the title. Okay, gg.title plus theme plot title element title adjust. So now the title's in the middle. Left adjusted. You can right center the title as well. Now it's over there. Okay, what else? Change the axis label and title programmatically by adding layers to the plot. Okay. Name feature of ggplot that can add more layers to previous plot layers. Instead of trying to build everything in one shot, you can build the plot piece by piece. Okay. Is this theme with plot? Add the title layer, theme layer. Okay. Also use the main ggplot function. It's just showing how to graph everything. No need to learn anything with ggplot. Okay. Power BI, we can run the R code in Power BI to get the Tesla stock data. That seems useful. Power BI resources and examples. And actual coding program is everyone in your team can know why you created the plot. Okay, this might be useful for the final project. Going back to R, you can integrate the same plot with Amazon. That's what the Amazon one looks like. Compact to get the historical stock price data. Get metrics on the performance of the stock and even test different trading strategies. Okay. Won't compare trading strategies in the class or in the homework assignment. Simply use simple daily returns instead of logarithmic returns. Okay. These expiry data. Ignore tax implications. Okay. Okay. This is the ticker date. That's the closing price. This is how you get the return value. So this one's on page 17. 117, 117. This seems like a good one. This is definitely in our assignment. Today's value minus yesterday's value. So this is the different prices. The daily return is positive. The price increase between the first and second day. If you bought $100 worth of it on the first day and sold it the second, you'd get 1.98. Okay. Without tax implications. Okay. Okay, this daily return was positive. Increase between second and third days. Interesting. Daily return between the third and fourth days. Okay. N is the total number of rows of the data frame. Then what is, okay, it's price of n. Return is n minus 1. 2 minus 1 is 1. 3 minus 1 is 2. Price n minus 1 or price n is okay. Entire column data frame values. For loop. Okay. Figure out we can get this right with calculations. Okay. So n is n row of Tesla data, gives the number of rows of the data frame. This is page 125. Starting with the second entry, this gives closing price for the consecutive days until the last day. Base price is this. Then you have the closing price. Starting at the first entry. Also, that one was starting at the second entry. This one's starting at the first entry. It gives the closing price for consecutive days until the second to last day. Okay, and then you have today's price minus yesterday's price over yesterday's price is the daily return. Okay, interesting. N row is listed, so these n's will all be correlated to that. Not only using that finding Tesla daily return or entry-wise operations means that when R computes the ith entry, or Tesla daily return, R takes the difference between the ith entries in today's price and yesterday's price and divides that by the ith entry in yesterday's price. Okay. Add it to the Tesla data. You can append NA for the first entry. If you want to add a column to pre-existing data frame, you have to make sure you have the same number of entries in the column as there are rows in the data frame. Okay. Wait, let's go back. What was this? Daily return is the NA is listed. Today's price, yesterday's price, over yesterday's price. You can append the first entry. Oh, okay. The same number of entries in the column as there are rows in the data frame. Okay. Study daily returns. Mean Tesla data daily return NA to RM is true. It's just normalized mean standard deviation. Okay, so how do we, oh, it says mean and standard deviation up here. Then the data is retrieved with that specific formula. First entry was NA. Okay. NA dot emit can also be used. Turns all rows with data frame which there are no NA values for that row will be removed by this function. Okay. Whoops, what did I click? I think I clicked on Google Lens by accident. Okay, 2 to n, no first entries in NA. You can tell her to ignore the first entry, okay? You can tell her to ignore that first entry. Oh, so the -1 makes it ignore the first entry as well. First one, okay, second to ignore plus data. Those radiations to collect more data. Okay, so web scraping will be used if you apply a numeric function to a column. Name output might be NA. Mean Tesla daily data return. Okay. Well, I guess this probably opened up to repeating vector sequence in ChatGPT. Maybe share a link. Interesting. Vector with numbers this. Okay. Very basic link. Okay. Numeric function, data, daily return, NA and above. Okay. If you try to apply numeric into a character data pipe and collecting data from the web, sometimes the data stores a character data type even with a numeric value. Suppose that x is below is some function from a column of character vector as the character. I wonder what this does. Example of character vector, mean of x. Oh, output was not numeric. Okay. Test the data daily return, plot daily return and count, make a histogram. Have this title adjusted. Okay. Create a data frame that has Amado's daily returns. Okay. Text symbol is this. Get symbols. The text symbol from Yahoo from this date. Have the ticker date as a date, the closing price as numeric with the name and specifically close. Okay, n rows. This seems like it's pretty useful, so will be good for the assignment too. Okay, yesterday's price, daily return. Okay. QQ plot, create a scatter plot of the values. Okay. So you can see all of this. Alright. The scatter plot of the values. Create scatter plots of from two data sets. Okay. You can omit some of the NAs and have a correlation. Tesla data daily return, NA omit Amazon data daily return. Okay. What else? Correlation with this. One metric of the correlation between random variables can be found in this probability folder. Okay, intro proceeding slides and slides from day one. Meeting slides will be helpful for homework one. Okay. Finance analytics. Okay, textbook quiz 2. This university textbook is either 100%. Okay. Or you typed the quiz twice. Okay. XOR, exclusive function. Okay. I've never seen these functions before. What else does it show? Your summing, logical operators. Okay. False statements. Logical operators, vectors, problem solving tips. Okay, that's all for that one. There's a lot of extra content in the day one slides, but let's see what was the useful information. Are any of these useful? Kind of, I guess. These are all just basic commands. Vectors, exponents, indexing, R norm, maxing, character vectors, strings, replacement with phone numbers, logical operators. Yeah, this was our very first class, so it was pretty basic. The in command, lubricate package, sequences, this might be useful. Yeah, Dippler library was pretty helpful and useful. Vectors, just going through several examples. Right. One-dimensional lists. Loading data. For loops. Okay. A lot of this is repetitive. Yeah, we saw this in the previous lecture notes as well. Yeah. There was some basics R file, but yeah, I think that's all I'm gonna